Okay, if you remember from our last time, we were talking about if statements and conditionals. So with conditionals, we were testing basically if a statement was true, and if the statement was true, we were going to print something out. So I've got some code here up on the screen. X, Y, Z is equal to 250, 115. If X is greater than or equal to Y, print X is greater than or equal to Y. If Y is less than Z, print Y is less than Z. And if we run this code, we can see it prints out 250 is greater than 100. The inefficiency with this code is that it's going to run each one of these tests separately. So for example, if I were to then write, what we might have written in our last program was something like this. If X is less than Y, then I want to print X is less than Y. And if you think for a moment, you might be able to realize why this actually doesn't make a lot of sense to have to check. Necessarily, if X is greater than or equal to Y, then this is not true. If X is less than Y, then this is true, and we don't actually have to check that. They're in what we call mutually exclusive, right? One is true or the other is true, but not both can be true and nothing else can be true, right? They're mutually exclusive, and they cover the whole space of possibilities. So we actually have some structures to help us with this. So let's go back for a second. Let's say, what if we wanted to test if X is greater than Y, just greater than, and print out X is greater than Y, and test if X is less than Y, but we only want to test that if the previous statement wasn't true, because again, if the previous statement was true, this one can't be. We would use an else if, which in Python is elif. It's written like this, E-L-I-F, and what this means is it continues the structure of the original if statement and adds another test. The idea being, if the first test is not true, it'll test the second thing. If the first test is true, it will skip over the rest of the code, and it won't waste our time testing things that we don't need tested. Now, you'll notice I removed a possibility from the first statement, which was this also equal to, right? So if I wanted to capture that again, I could do this using our comparison equality comparison operator, right? Print. And then we do another if statement, and we would say X is equal to Y. And now we've covered all the possibilities, but we've covered them in a way. So it says 250 is greater than 100. That's correct. If I change that, 25 is less than 100. That's also correct. If I change this, we will see 25 is equal to 25. So our code is working perfectly. We're covering all the conditions. But I want to talk about this last one for a second. This last one is an example of where we actually are already covering all the possibilities, and we just want to catch what's left, right? And equality actually is the only thing that's left. But in other scenarios, maybe we don't know all the things that are left, but we want to capture all of them. So what we do is, instead of doing an elif, we could just do an else. And an else is nice because notice I didn't have to put a test in there. It's saying if X is greater than Y, print this. Else, if X is less than Y, print this. Else, if any other case is true, go ahead and print this. And you'll notice our code runs exactly the same as it did before, catching the equality in the else statement. We could also, so bringing in Z for a second, we can also do something called nested if statements. Nesting of code is a fairly common phenomenon when you want to test a few things. So let's say we wanted to build a script that printed out the number that was the largest number, the greatest of the numbers. To do that, the first thing we have to do, I'm actually going to just take all of this out. We've got these three numbers, 25, let's say 5, and 15. And we want our code to print out the greatest of these numbers. Before I start coding, I want you to start thinking through what the steps would be for figuring out which one of these is the greatest number, and then how might we go through using conditionals like if statements to figure that out. So and the process you're going through right now is what we call computational thinking, right? You're looking at the situation. You're trying to recognize what kind of patterns there are in that situation, and then you're going to abstract from those patterns a step-by-step process, we would call it an algorithm, for solving these situations, right? So we're not always interested in the numbers 25, 5, and 15. We're interested in the set of all integers, all sets of 3 integers. we want to look at and be able to follow the exact same steps every time to get the right answer. So let's look at what we need to do. So if we're setting up an algorithm, for solving this problem, we need to think about the steps we need to complete to solve this problem. So for example, step 1, what might we want to do? Well, the first thing we might want to consider doing is comparing x and y. Let's think about what information that gives us. If we compare x and y, we're going to know which one of those is greater. And thus, we're actually going to eliminate one of the two possibilities, because if it's not greater than the other one, it automatically can't be the greatest, right? It could be equal, and then we'll have to look at that. That's what we call an edge case, where it's maybe not the center of the thing we're looking at, but it will come up and we want to plan for it. But we'll take a second on that for the moment, and just let's assume they're all distinct integers. So if we compare x and y, we're going to know which one of those two is greater. Step 2, compare the greater of those two to z. So now we're taking the greater of those two and comparing it to z to see which of those two is greater. If we then take the greater of those two and print it out, we'll be printing out definitely the greatest integer of these three. So in this case, we want to do two comparisons. We want to compare x and y. We want to compare whatever the greater of that is to z. So we're going to need our nested conditionals. And by the way, congratulations, because you wrote an algorithm, right? That's an algorithm for solving this problem. So let's go ahead and do our comparisons. So let's compare x and y first. So if x is greater than y, do something, right? I'm just going to put a print statement there for now. We don't know what we want to print, but just so we don't have the error of the code, we want to print something. If x is not greater than y, we want to do something else. Do we have to write an if statement there? Do we have to write an else if? Or can we get away with an else? In this case, I would argue we can actually get away with an else. So that is the result of comparing the first two. Now that we've compared the first two, we need to continue on to step 2. And step 2 is actually going to happen kind of in two different places, right? In this case, we want to compare, if x is greater than y, we want to compare x to z, because x is the greater of the two. So we write another if statement to say, well, what if x is greater than z? Well, then if x is greater than y, and inside there, nested inside there, we test and find out x is greater than z, well, at this point, we can confidently print out that, in fact, whatever value x is the greatest number. Now, we've done step 1, and we've done half of step 2. But we haven't considered the fact that what if x is not greater than y? What if y is the greater of the two? Well, that has to happen down here in the else statement. And then we have to say if y is greater than z, print y is the greatest number. Okay, so now we have code that gets us if x is the greatest number. We have code if y is the greatest number. What if z is the greatest number? Where does that live in this program when thinking about our algorithm? In terms of where this lives in our program based on our algorithm, well, it actually kind of lives in more than one place, right? So if we look at this code right here, where we're looking at x is greater than z and y is greater than z, we actually say, okay, in this case, what is the opposite? What happens if x is not greater than z? Well, that's actually the case where we want to say, okay, z is the greatest, right? Z is the greatest here. So we'll go ahead and put that here. Z is the greatest number. And that has to live in more than one place, right? Because that comparison is happening in more than one place. It's also happening inside this else statement. So we get another else statement in here. Print f string that z is the greatest number. Okay, so you see that we're actually printing that in both places. Now let's actually try our code out. So if we're doing this properly, it should print out that 25 is the greatest number. 25 is the greatest number. Perfect. Let's go ahead and change this to 50. Now it should print out that 50 is the greatest number. 50 is the greatest number. Now let's change this to 150, and it should print out that 150 is the greatest number. Perfect. So you see our algorithm works, which is great, and it doesn't matter which of our variables we set as the greatest number, they all end up working out, printing out properly. Okay, so we talked earlier about the edge case of like, what if some of these are equal, right? We have no equality checking in here. Well, it actually doesn't matter, right? Because if 25 is both y and z, x and z, when we come here, x is not going to be greater than y, right? Because 25 is not greater than 25. It's going to come down to this else statement, and then it's going to check against z. So it doesn't actually matter which numbers are equal or not equal. It's always going to catch the right number with the logic that we've used. So we've written a really good algorithm that does, in fact, catch the right number every time, no matter how we do our comparisons, and then uses that number for our program here. Okay, and that's pretty much it with conditionals. So our next thing is we're going to be moving on to a big project.